Hello friends, welcome to my channel Lifelong Learning. We have already seen the tools available under what if analysis, Goalseek, data table and scenario manager. Suppose we want to perform a what if analysis that is beyond the scope of these three tools, then we go for solver. In this video, we are going to see what is a solver and how to activate it. Solver uses techniques from the operation research to find optimal solution for all kind of decision problems like this. Transportation, assignment, shortest path, product mix, maximum flow and capital investment. Optimization problems are nothing but maximizing the profit, minimizing the cost or time. Solver comes pre-installed with both Windows and Mac versions of Excel. It is available under the Data tab in the Analysis group. If you have already installed it, you will get this solver here. But if it is not available, we need to do it manually. Now let us see how to enable the solver add-in. To load the solver add-in, on the File tab, click this Excel options. You have add-ins here. You can click this drop down. Here you can see that Excel add-ins give go. It shows you what are the add-ins available here. If the solver is not clicked in, you can just click it. This is how we enable the solver add-in. Give OK. Then it will be available in this analysis group under this data tab. Before we see how solver works, we quickly compare it with the Goalseek analysis using a simple example. In Goalseek, we are restricted to changing only one variable. If we have multiple variables along with some situational constraints, we can use solver for advanced what if analysis. In this example, I have 100 items to sell. I want to sell certain percentage of these items at a higher cost 65 and the remaining items in the lower cost 45. I get a total sale of 5,900. But if I want to fix the total sale as 7,000, I am going to use Goalseek. I click this cell. So what is the set cell? It is H5. What is the value I want to set? It is 7,000. And what cell I have to change? Here I have the option of changing this percentage as well as its unit price. But I can give only one cell here. So let me select this percentage. I give OK. Now you can see that I have got unreasonable percentage. But if I am allowed to make changes to all these variables, I may come up with the optimal solution. But if I want to put a restriction on this highest percentage, 125 is unreasonable. It should not exceed 80%. I cannot use this Goalseek. In Goalseek, I cannot alter more than one variable and impose any restrictions. If I use solver to solve this problem, I click solver. What is the target cell? Target cell is nothing but this H5 and it is equal to, I can maximize it, minimize it, or I can set a value. Here I set the value as 7,000. And what cells I can change? I can select this one and these two. I'm using a control key to select these two. I'm not specifying any constraints, but let me solve it here. So you have got 125% as before, but I can set a constraint here. Go solver. What is the constraints I want to set? I want to set this should be less than or equal to 80%. Since it is a percentage, I just give 0.8. Then I give OK. So percentage sold for the highest price is less than or equal to 80%. Now I give a solve. You can see that 80% of the book I can sell it for 76 and remaining 20% I can sell it for 48%. So I get the answer here. I can change this percentage as well as the highest and lowest price. Hope you have understood how solver works. Now we'll see a real example of optimizing the profit. A cycle trader sells these three types of products in his shop. The unit profit of these products are given here. He has to invest a capital of 300, 420 and 200 to purchase these items. But he has a capital of 30,000. That means he has to buy the products not more than this amount. He also has a storage cost. The allowable storage cost is 100, meaning that the products he is purchasing should have a storage cost less than this 100. Now he has to decide how many of these products he can buy and still have a maximum profit. To solve this problem, to find the optimal value of a formula in one cell, this is called the objective cell, and subject to the constraints on the values of the formulas on other cells. Solver works with a group of cells called decision variables or simply variable cells that are used in computing the formula in the objective and the constraint cell. Solver adjusts the values in the decision variable cells to satisfy the constraints and produce the result you want for the objective cell. Put simply, you can use solver to determine the maximum or minimum value of one cell by changing the other cells. The model we are going to solve looks like this. So to formulate this linear programming model, we have to answer three questions. What are the decisions to be made? For this problem, we need Excel to find out how much of this order of each product we must make. What are the constraints on these decisions? The constraints here are the amount of capital and the storage cost used by the products. And what is the overall measure of performance for these decisions? The overall measure of the performance is the total profit of the three products. So the objective is to maximize the quantity. To make the model easier to understand, I am going to create named ranges. This range is for the unit profit and this range will be called as a capital. This is for the storage cost. So I select this, go to formula, create from selection. The left column is clicked here. That means these three cells will be named as unit profit. Likewise, I give names for this capital, storage cost, order size. This will have the name in the top row. Same thing here. Now I have to insert three functions. One to calculate the capital for all the order size. Similarly, we have to calculate the storage cost for this order size. So same thing here. This will be the sum product of capital into order size. This will be the sum product of storage cost into order size. Sum product of unit profit into order size. Now I call this solver. What is the target cell? The cell which I want to maximize it. So this one. Here I want to maximize. What is the changing cells? What are the decision variables? Or nothing but its order size. What are the constraints? This G7 should be less than or equal to this resources available. Similarly, the storage cost should be less than or equal to 100. This order size, I just want to have a minimum quantity. So it should be greater than or equal to 10. Now I go for this solve. You can see that I can order 10 bicycle, 60 mopeds and 10 child seats so that my resources will be 30,000 and the storage cost is 32 only. It is much lower than 100. But I have exhausted all the capital resources available. So the profit will be 12,166. Now I give OK. Or I can save it as a scenario and then compare it with the other values also. Here I give OK. In this video, we have seen what is a solver, how to activate it, and how it is different from a Goalseek, how it can be used for optimizing a particular cell value. Hope you like this video. Give a thumbs up if you like it and share it with your friends. Don't forget to click the subscribe button and the bell icon so that further videos will reach you.